السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. معكم مستر حسام حسن، منصة البث المباشر وزارة التربية والتعليم. نرحب بكم مع تحياتي وتحيات فريق المنصة. طبعا احنا بدأنا الريفيجن من المرة اللي فاتت، وقلنا ان الريفيجن بتاعنا هيتقسم إلى جزء خاص ب ريفيجن. كل شابتر هياخد له ما بين 2-3 سيشنز، وبعد كده هيبقى فيه جنرال كامل في اللي هو بسميها الفاينل اكزامز، استعدادا لدخولنا للفيرست ترم في الامتحانات ان شاء الله اللي داخله في الفتره القادمه. طبعا النهارده هنبتدي نعمل solving ل some problems in this first slides in 2MOH by 3 plus 3H2SO4. احنا بنحل مساله هنا. The results is M2SO4 by 3 plus 6H2O. The metal M is most like، يعني هنا عايزين نفهم هنا most likely what؟ sodium or magnesium, aluminum or potassium. We have many examples. We have many probabilities about these elements. The true answer is aluminum or magnesium, sodium, potassium. This depends on the valency of these elements. So we must save before the valences of total elements. We have sodium monovalence, magnesium divalence, aluminum trivalence. Yes, so aluminum is true. Aluminum is the trivalence, and we can to write the molecular formula of MOH by 3 equal to ALOH by 3. Okay, next questions. The number of the atoms in 0.5 moles of acetic acid CH3COOH equals 2. Now you must numeric these numbers of moles of the components of acetic acids. Now you must solve this problem by using essay way, not choose the correct answer. And you can to write the true or the correct answer, so you can choose the correct answer. The number of atoms in 1 mole, firstly in 1 mole, we have this 0.5 mole. Firstly, you must know number of moles here. Okay, count with me. 1, 4, 5, 6, 7, 8. This 8 moles of atoms in 1 mole, so the number of moles in half moles equals to 4 moles. Okay, 4 moles. Okay, this is the true answer, equal to 0.5 times 8 equal to 4 times. We have Avogadro's number, no. Double, no. 4 times, yes, this is true answer. This is true answer for the last questions. Now we have how many moles of Na are in 7.53 times 10 power 22. We will use Avogadro's number for the solving this problems. How many moles of Na? This Na is 1 mole of atom. Okay, you must divide this number to 6.02 times 10 power 23. You must write this in your calculators to calculate the true answer equal to, when you divide 7.53 times 10 power 22 over 6.02 times 10 power 23, so the answer equal to 0.125 moles. So the true answer is B. True answer here is B. Now you must know how can you choose the true answer. Choosing a true answer depends on the essay way, not you write these numbers and you can to calculate this at any way. Number 4, the number of ions presents in 0.5 moles of K2O. Now we have K2O equals to 2K plus O. We have 3 mole of ions. This problem depends on number of total ions, not oxygen ions or potassium ions. Now we depends on K23, K21, so this is 3 moles of ions. 3 moles of ions, if 1 mole, so 0.5 mole equal to 1.5. Okay, we must show the choices. Now we have 3.01 and another. Okay, what is the correct answer here? Now we calculated equal to 3 moles of ions in 1 mole. So we have 1.5 mole of iron in 0.5 moles. But we want the number of ions, not number of mole of ions. Okay, this is easy. You must write 0.5 times 6.02 times 10 power 23. So the correct answer is this, B. Why? This is B or D. Now we must write the 0.5. Oh, yes. 1.5 moles. So multiply 1.5 moles times 6.02 times 10 power 23. Okay? Okay, you can recalculate with me to ensure my calculation is true. So maybe I'm not correct, but I calculated correctly. Now we have 1.5 moles ions times 3 times 0.5. Now the actuals is here equal to not B, not CD. This is actual. D is the correct answer. Now you must know the way how calculate it. Okay. Now we transfer in problem number 5. Problem number 5. Dissolving 1 mole of NaCl completely produces a total number of ions equals to. Focus on these problems to know how you can calculate the number of NaCl when it completely dissolves. It's ionized into Na positive and Cl negative. Okay. Total numbers of ions equal to Na, 2Na, 3Na, 4Na. We have what the meaning? Na like sodium? No. Na, it is Avogadro's number. I mean Avogadro's number. Okay. NaCl. Na, this is ion Na. Cl is ion Cl. Now NaCl, we have 2 moles of ions. So 2 moles of ions equal to 2 times Avogadro's number. This is answer. This is answer. Okay. Now transfer here in this questions. Number 5 depends on how to calculate it. So number 6, how many ions are found in 16 grams? Now we have the mass, not number of moles, not number of ions, not number of particles. We have 16 grams of what? Anhydrous CuSO4. CuSO4 copper sulfate. Okay, you must using these numbers. I will Cu equals 3.5. This is a molar mass of copper. Sulfur equal to 32. Oxygen equals 60. Now, first way or first step, you must calculate copper equal to 63.5 plus 32 plus 4 times 16 equal to 159.5. This is a molar mass of anhydrous copper sulfate. So 16 divided the molar mass of copper sulfates equal the number of moles of CSO4. Now, how many ions are found in 16? Okay, CSO4, 1 mole of CSO4 equal to 2 moles of iron. Okay, 16, if you divide 16 into 159.5 equal to number of moles of iron. I'm sorry, number of moles in CSO4. Okay, this is copper sulfate 190.5. So the number equal to 0.1 moles. So we have 2 moles of ions times what? Times 0.1 times Avogadro's number. This is, so the answer is number A, 1.2 times 10 power 23. Now I repeat the way again. We have divided 16 to 159.5, approximately 160. Now 16 to 160, so the 0.1 moles of the CSO4. 1 mole have 2 moles. 1 mole have 2 moles of ions. So 0.1 moles of CSO4 equal to X. X equal to 0.1 times 2, 0.2 moles. You must multiply 0.2 into 6.02 times 10 power 23 equal to 1.2 times 10 power 23. You must write when I explain the way of this problem, you must write to understand what I mean, and you have calculations to have a good calculation or true calculation or accurate calculation. A sample of O2 of mass 8 gram contains the same number of atoms as 16 gram of elements X. The gram atomic mass of X is, okay, now we want sample. Now you must write that, you must understand that sample oxygen O2 of mass 8 gram. Okay, 8 divided 2 molar mass of oxygen. Molar mass of oxygen equal 2 times 16, 32. 8 over 32 equal to 0.5. Okay, now we have the same number of atoms as 16 gram of elements X. 16 elements X. Which element X? Okay, you must have the same numbers, atomic mass of X. Now it is easy to correct it. Answer is what? Is D. Is D. Why? Because we have 8 gram of oxygen, 0.25 moles molecules I calculated before. Okay, now 16, if you multiply 0.25 times 2 times 16 equals 32. Now the molar mass of this is oxygen. This is oxygen. Oxygen equal to 32 gram per mole. Now we use the molar mass of anything you want, and you can to calculate it by using the periodic table you have in your concepts paper. The molar mass of barium sulfate, BaSO4, you must have the molar mass of each component. You must write barium sulfate is BaSO4. Have Ba equal to 137, okay, S equal 32, oxygen equal to 16 times 4. Now barium sulfate is what? Is 233. How did you know that? Because I'm using the ways to calculate the molar mass of BaSO4. If you write barium sulfate incorrect, so the way or the application is not true. The application, how we have this number equal to BA 100. Okay, must write that we 100. This is 100 variant B 137. Okay, 137 plus 32 plus variant. I'm sorry. I'm very sorry. Sulfide. I read it wrong. Sulfide, not sulfate. Sulfide. If sulfide is the true answer is B, but sulfide SO3. Sulfide SO3. I will I will rewrite the or recalculations that BA 137 plus S32 plus 3 times 16 equals 217. Now, I told you before, if you write the molecular formula wrong, your calculating is not correct. Okay? Now, we transfer another 9. Which of the following have the least molar mass? Water, carbon dioxide, methane, hydrogen chloride. Okay, water H2O, carbon dioxide CO2, methane CH4, hydrogen chloride HCl. These these questions these questions make training for you to write the molecular formula or writing of true molecular formula. This is H2O equal to 18, carbon dioxide equal to 44, methane equal to 16, hydrogen chloride HCl 36.5. Now you don't save this number, but this number you calculated it. When you calculated, you want what? You want the least molar mass. We have H2O is the least 18, or carbon dioxide 44 is the least, but we have 16 in C, so the methane is the least number of molar mass in these choices. Okay, number 10, the number of moles of H2S in 49.75 grams of it is equals to the same way. H2S, you must calculate molar mass of H2S. When you calculate it is true, now you can divide it 49.79 into 2 plus S into 34. Okay, now you must be using the calculators, so you have the correct answer now. It is easy to correct the answer. Now, we have 34, it is the molar mass of H2S. Now, you must know the number of moles equal to 49.79 divided to 34. Now the true answer is 1.46. Now the choosing is B. Choosing as B. Number 11. So what is the total number of moles of oxygen atoms in 240 grams of NH4NO3? Okay, the same ways you must writing the molecular and you calculate the molar mass of NH4NO3. Now the molar mass of NH4NO3 equal to 80 gram. So we have 240 gram of NH4NO3 must divide it to this number equal to 3 moles. Equal to 3 moles. If you want the number of moles equal to 3, if you want the number of molecules, 3 times 6.02 times 10 power 3, anything you want, you can to calculate it easily. If you say the laws you want to use and calculations. Okay, this is the true answer. True answer is 3 moles. Mass of carbon in 2 moles of calcium carbonate. We have 1 mole of carbon only. When mass of carbon in 2 moles, okay, equal 2 moles of carbon, 1 carbon equal to 12. Do you ask me, Mr., how can I know the molar mass of carbon? I told you before, you have a table. These tables have molar mass of each element. You must use these numbers to calculate the molar mass of anything you want. Okay, now we have many choices: 24 or 12, 6, 0.48. Now we have two moles of T, okay, times into 12 equal to 24, so the correct answer is A. The mass of 0.25 moles of Na2CO3 equals to. Now this mass equals this number equals to this number. Now we have 106. Okay, this is mass, molar mass of Na2CO3 equal to 106. 106. Now 25, 0.25 multiply into 106. Now this equal to 26.5 grams. Now the true answer is B. True answer is B. Okay, if the mass of 0.006 moles of oxides of phosphorus equals 1.704 gram, the molecular formula is. Now we have weigh. If 1 mole, this is a molar mass, equals to phosphorus equals 31. Now 0.006 moles of phosphorus equal to 1.704. Now you can to write the molecular formula, and you can write the molar mass of phosphorus if you don't know that. Now we have 1.704. Now the molar mass equals 31. Equal, you must know the number of moles of P and these compounds oxides. By using the divided of this number to this number of moles. Now we must know the molar mass. We have P4O10. Now we have 284. So the answer is C, P4O10. Okay, number 15, which sample contains the least mass of oxygen? Now, each sample contains the least mass of oxygen. We have many choices. Oxygen, oxygen, oxygen. This is choices for the answers. What's H2O? We have 1 O. O2 we have 2 O. But you must focus in this number. 0.8, 0.7, 0.3. These choices. Okay, you must know the way to calculate it. Firstly, you must try for each to know the least number. Oxygen mass and HCOH equal to 0.6 times 32 times equal to 19.2 K. In H2O equals 0.8 times 16 equal to 12.8 grams. Oxygen equal the same numbers. Oxygen here equal the same numbers. Now the smallest is 12.8. 12.8. 12.8 here. This is H2O. So the H2O is the simplest or the least number of oxygen, least mass of oxygen in 0.8 moles of H2O. What is the number of molecules in 43.5 gram sample of ammonia? I want to know the number of molecules. You must have the number of moles, but I have the mass. You must convert the mass by using a molar mass to number of moles, and the results multiplied in 6.03 times 02 times 10 power 23. Now you have the calculations good. Go. Okay, show that I told this before. 43.5 divided into 17, the molar mass of ammonia gas, so equal 2.559 moles. Now this number you must using to multiply in 6.02 times 23. Now the true answer is 1.54 times 10 power 24, where this is C. The answer is C. Okay. The mass of one molecule of propanol. What's the meaning of propanol? This is incorrect for you, but you must focus the molecular formula of propanol C3H7OH. Approximately how the mass of one molecule. I don't mean one mole. I mean one molecule. Okay, one mole equal to 3 times 12 plus 7 times 1 plus 16 plus 1. This is a molar mass of propanol. Okay, molar mass of propanol. How many molecules? Equal to 6.02 times 10 power 3, 10 power 3, 23 inside. Okay, okay, one molecule equal to, oh yeah, now we have the molar mass of propanol, and I have the number of molecules of each mole of propanol. We want one molecule, so multiply 1 times the molar mass of propanol and divide it to number of molecule, the constant value. Okay, the constant value. So the answer is A, 9.97. Okay, you must recalculate the steps I show you to ensure my answer. 1 mole of nitrogen combined with 3 moles of hydrogens to form NH3 in amounts except 1 mole of nitrogen combined with 3 mole. This is to prepare ammonia gas, N2 plus 3H2 produce 2 NH3. These examples for training the balanced ways to form ammonia gas in amounts except. Okay, now we have the choices to mole 34 grams 2 times 70. 2 moles ammonia gas. Okay, this is true because N2 plus 3H2 produce 2 NH3. Okay, 2 moles equal 34. Yes, 2 times 17 equals 34. Number of molecules, this is true, times 2. This is incorrect. 17, this is 1 mole only of NH3, but we have 2 moles of NH3 in the equations. How can I know? Write the equation, and you must balance the equation to ensure that. You must balance it good. 4 gram of NaOH contains this number of atoms, number A, or this number of mass of Na, or this number of moles of NaOH, or this number of ions of Na. We have 4 choices now. So correct answer is D. Why is D? Because 4 grams, when you divided 4 grams to 23, you have 0.1. I'm sorry, if you divided 4 to 40, 40 the molar mass of NaOH equal to 0.1. 0.1 if you divide it into 6.02 times 10 power 23, so the number of ions equal this number of ions. Well, now this is a correct answer is D, because we have multiplying in this number 0.2 in the Avogadro's number. 1 mole of hydrogen at STB, standard temperature and pressures, contains each of the following excepts. I told before what the difference between STB and RTB. STB, standard temperature and pressures, 0 degrees centigrade and 1 atmosphere of pressure. But we in the room temperature 25 degrees centigrade and the same pressure 1 atm. So as hydrogen equal to, and this in this conditions at STB contains the following, except we search here the incorrect answer, not correct answer. Okay. Okay, we have many answers here. 6.02 times the 10 power 23. Yes, molecules of hydrogen. Yes, is correct. 2 gram of hydrogen. Yes, this is correct. Okay, 12.04 times 10 power 23 atoms. Okay, this is correct. 1 gram of hydrogen, incorrect. So this incorrect, but it's correct answer because the actions here accept 3 true answers, but we search to the incorrect answer, not correct answer. Now we discussed before, to understand good in this chapter you must training goods in these answers, and you can do make a training of yourself to make many examples. These examples help you to know each things to using the balances of equations or calculation of molar mass of anything. Sample of oxygen of mass 32 grams contains, we have 4 choices. Correct answer is, you must know the way firstly you can to choose again. Okay, sample of oxygen O2 equal to 32 grams contains, okay, why 1 mole? Because oxygen equals 60, equal to 60. When you use 2 times 16 equal to 32 grams. Okay, now in this 1 mole equal to atoms, okay, 2 atoms or 2 moles of atoms, this try 2 times 16 equals 32. Okay, now you search here 6.02 times 23 oxygen atoms. This is 1 mole of oxygen. Now 1.204 times 10 power 20. No, this is not good. The same number of oxygen atoms found in 30 gram. Yes, this is true, because H2O have 1 mole of oxygen. 1 mole of oxygen. This is number of mole of oxygen atoms equal this number. So the C is the correct answer. C is a correct answer. Now we finished the solving some equations, some problems before. Now we have another session for revisions to the next laws. Now, before we finish this session, we collected some revisions about some definitions, some differentiation, some concepts about some things. We have this reactance that runs out firstly and determines the maximum products. Now, you must know, firstly, you must write equation. Now, when you write good in your equation, you must balance this equation. Convert all given. You must convert all givens to moles, to volume, to molar mass, to anything you want according to the questions. This is computing for each reactance. Okay. Now we honey. This is ratios, small number of moles given to moles required by coefficients here. The smallest ratio, you must know, the smallest ratio is the limiting reactant. I told you before, limiting reactant, it is a reactant consumes totally in the reactant. Okay. Now, this is very important to know the illustrations for about this reactions. We have 2H2 plus oxygen equal to 2H2O at RTP. So the volumes here of water vapor or hydrogen or oxygen, we have 24 liters of hydrogen and 14.4 liters of oxygen. So hydrogen is limiting reactant because the hydrogen will totally removed, totally consumed in this reaction, because have the least ratio of these reactions. Okay, okay, this is a way to know the least number of moles according to this reaction. And we have 3Fe plus 4H2O produce Fe3O4 plus 4 hydrogen, 16 gram 0.8 iron reacts with 10 gram of water vapor. So Fe is the limiting reactant. How can you know that? Because you must know the ratio between Fe and oxygen according to 3 to 4 or less than this number. F equal to the ratio, because we have no. But we must know the least number, it is the limiting reactant. Okay, now we have CaO plus H2O COH by 2. This is produce this number. We have many types of formula, molecular formula. This is actual formula. We have empirical formula. We have structural formula. This is number of actual number of any atoms inside the molecular formula. But in the empirical formula, it is the least number of atoms in the empirical formula. Structural formula show the shape of the atoms and the bonded between the atoms in the space. We have 3 dimensions like in organic chemistry, but we have in inorganic chemistry, it is important, it's not important to know the structural formula now. Now, the steps for masses assumes 100 of converting percentage. You can to know the converting of the mass to percentage, partial to total times 100. Assume 100 grams converted percentage to gram, compute small divides each by the smallest multiplies to clear fractions. This is number reach integer. Must have examples. These examples equal 17.5 percentage sodium, 39.7 percentage chromium, and 2.8 percentage oxygen. We have many percentage of many things, and this example you must convert this percentage into number of moles. So if you have number of moles, it's actual number of moles, but this number is fractional, not integer number. You must convert into integer number. Okay, you must firstly convert this fractional number into integer number. How can you do that? By division this number of moles to the least number, this number of moles here. Now, if you apply this and sodium, chromium, and oxygen, so the ratio is 3.53 times 3 equal to Na2Cr2O7. Now, you can to obtain the molecular formula or empirical formula from the percentage of each atom in the components of resisted molecule. Now, computing of these things, computing of these things is 2 molar mass of this molar mass. You must divide the molar number mass to molar mass, and you know the combustions analysis here. Hydrocarbons like CXHY, X moles CO2 produce 1 mole compounds. Okay, Y 2 times mole H2O produce 1 mole compounds. This is a hydrocarbon. When any hydrocarbon combustions the air, it produces CO2 H2O. If you know the number of H2O, you will predict the number of mole of hydrogen, and you can to predict the number of mole of carbon by using the number of mole of carbon dioxide. We have C3H3O. If you burn these compounds, it use 3CO2. And we have this number of hydrogen equal to H2O2 divided 18 to know the number of mole of H2O produced in this reaction. Okay, now when you using the hydrocarbons here to calculate the number of moles of this component, now you must know that the component, and next session we will reduce the problems to take your time to understand how can you obtain the molecular from the combustion molecular formula from the combustion of any hydrocarbons compounds. We know the concentration for using molarity and ion concentrations. Now molarity equal to number of moles divided to volume of solution per liter. We have N underscore solute, I mean number of moles of solute. V underscore solution liters, I mean the volume of solution per liter. Now we have M times N times M. This is molar mass. This is to know the mass of this substance. Ion concentrations applies dissociations. Take chemistry example K2SO4. When it dissolved, it obtains 2 K positive plus SO4 negative 2. If you have 0.4 molar salts, 0.8 molars K, 0.4 molar SO4 negative 2, it is the number of ions used. What the meaning of the dilation process? Dilation process, if you have anything so like acid, salt, or have a definite concentration, and you make for this concentration, you make dilutions for this. You add excess of amounts and know these numbers of liters you add in this solution. Now the concentration is decreased by addition excess amounts of water. Now you can to apply the dilution law. M1 times V1. M1 is the concentration before dilution. V1 the volume before dilution. M2 concentration after dilution. V2 the volume of solution totally. I mean if you have 100 milli and you add 300 milli, so V2 equal to 400 milli, because V equal to V1 plus additions. Now we can do using this law to calculate molar of concentration after the dilution. Now we finished our session now, and we will next we complete these according to some examples and some training and some problems. Now thank you for good listening, my dear peoples. Wassalamu alaikum wa rahmatullahi wa barakatuh.